Okay, lab 5 and 6 are combined together, so they'll be performed consecutively. Okay, so we'll study about the formulation and then how different formulation will affect freeze-drying conditions. And once we freeze-dried differently formulated drug vials, and we'll inspect those freeze-dried drug vials using different parameters. That's the plan for this lab. So this two combined lab will take 2 weeks of the time duration. Okay, so part 1 is formulation and freeze-drying setup. So we will test 3 different drug formulation. Okay, so these are the formulation recipes. Number 1 formulation is just 3% mannitol. So actually the API is not added there. So we're just testing the effect of different cryoprotectant or lyoprotectant or salt in the freeze-drying condition. Okay, so the first formulation is just made up with 3% mannitol only, which is good cryoprotectant. Okay, so you will dissolve 3% mannitol in UFI. Okay, and then you'll do the sterile filling of vials, and you'll set up the freeze dryer with that. And the second formulation is 3% sucrose. Sucrose is a lyoprotectant as well as cryoprotectant, depends on your formulation. And then that sucrose, 3% sucrose, is combined with 1% sodium chloride. As you know, sodium chloride is a salt, right? Table salt. So normally it's used as a tonicity adjuster. So 3% sucrose and 1% sodium chloride will be mixed up together. So that will be, formulated and then filter sterilized and filled in vials. And the last formulation is 3% sodium chloride. So just the tonicity adjuster only, 3%. Again, you will prepare it, sterile, filterize, and then vial fill. So I want to have you walk in maybe 3 different groups. So one group will formulate one formulation recipe, and hopefully each group will sterile fill a number of vials. Okay, so first thing is dissolving each formulation into UFI. I want you to make enough solution to fill about 10 vials, about 2 ml in each vial. So it's going to be about 20 ml total. So if you make about 25 ml solution volume, I think that may be enough for your experiment. So each group will make about that much of solution. Okay, so once the solution is completely dissolved, so you will have to measure out 3% of solutes and then dissolve in UFI, and then once they are dissolved in maybe beaker with stirring bar and on a stir plate, and then you will have to final volume check, see if it's 25 ml. Once that's done, and you will have to filter sterilize it. So we'll give you 0.2 micron disc filter that you can attach to the tip of syringe. So you will do a sterile filtration using syringe tip filter. Once your solutions are sterile filterized, you can collect those filterized solution on maybe 25 ml sterilized conical test tubes, and from the conical test tube you can fill the vials that are, washed and sterilized. Okay, and you'll do that aseptically, so you'll have to use a biosafety hood with a sterile pipette and pipette aid. Okay, so once your vials are filled aseptically, then you will have to place rubber stoppers. Those stoppers should have the evaporation channel, so we call them lyo stoppers. They typically have 2 legs, which will generate evaporation channel. Okay, we'll show you what they look like. So that's the first part. So formulating 3 different solutions. So maybe each group will formulate 1 solution, and then once you completely dissolve the solution, you filter sterilize it, and then fill aseptic fill about 10 vials. Okay, you may need to label your vials as well. So there will be 3 different formulations. Okay. So once your vials are all prepared with the stoppers, and you will carefully place them on a metal tray that will be placed into a freeze dryer. So you need to place all the vials into onto a sample loading tray. That's a metal tray. I'll show what that looks like, and then we'll move that metal tray that has probably 30 vials with 3 different formulation into a freeze dryer. Okay, freeze dryer will not be located in S104. It is located in a different lab, so we'll move them. And once those vials on a tray is loaded onto the shelf of the freeze dryer, okay, and we'll have to place thermocouples, okay, the temperature sensors in 2 of the vials with the stopper removed, and we'll have to tape the temperature sensor onto a vial, and then we slowly close the door of the freeze dryer, so there will be no vacuum leakage happening. Okay, so that's how you're going to set up your vials into freeze dryer. Okay, once that's done, we'll program our freeze drying condition on a freeze dryer. Okay, so typically you're going to learn about freeze drying process and freeze drying principle, but in a typical freeze drying cycle, there are about 5 different steps in a freeze drying process. Okay, the first step is normally product freezing. Okay, so you'll slowly freeze your drug on a temperature controlled shelf. Okay, so the freeze dryer will freeze your sample first. The temperature will cool down kind of rapidly. So in our case, we'll use minus 40 degrees Celsius. Will cool our product to minus 40 degrees Celsius. Within about 130 minutes of time, we'll slowly bring down the temperature. So it's a ramp. R means a ramp. Okay, temperature change from whatever room temperature setting is, maybe 25 degrees Celsius. It's going to drop down to minus 40 degrees Celsius because your freeze dryer is capable of freezing with the temperature control, strong condenser. Okay, so about 2 hours and 10 minutes of time will take to freeze just drug, formulated drug. Okay, so with the slowly ramping the temperature, and then we'll keep that temperature there for about 30 minutes. Okay, so primary freezing including the ramping time and then freezing time, so total 130 minutes and 30 minutes of 160 minutes will take to get your product frozen. So that's the primary freezing step, and once that's done, okay, we'll start vacuum pulling. So by this time, about it's about what 2 hour, about 40 minutes. Okay, your vial should be all frozen, especially what's in there. Okay, and then we'll start a drying process first. Okay, so after freezing is done, normally there's a between the freezing, primary freezing and a vacuum pull, there could be a the annealing process, annealing or thermal treatment processing, which is maybe slowly raising up the temperature and then freezing down again. We'll talk about this process in the lecture, but that's a kind of an optional process. But in our case, we're not going to add that step. So after primary freezing, we're going to just vacuum pull. So, but understand there is an optional annealing process that can be added after primary freezing. Okay. So in our case, we didn't start. We skipped that annealing step, and then we directly went into primary drying step, which will increase the temperature from minus 40 to minus 35. Okay, after slowly increasing the temperature, you're gonna start pulling the vacuum. Okay, so there's a vacuum pump attached to your freeze dryer, so it'll pull the vacuum. Okay, so at this pressure, so about 100 millitorr pressure. Okay, so R again is ramping, so your vacuum is slowly increased from 0 to 100 millitorr. Okay, the pressure. Okay, so that's primary drying. So during this time, hopefully, water crystal will be slowly vacuum pulled. So we're going to talk about the process. But once your water is frozen, So it can go into vapor stage without going through the liquid stage. We call the process sublimation, right? Sublimation. So this under this condition, sublimation will take place, meaning water crystal will evaporate directly. Okay, that's what's going to take place. So once we reach that temperature -25 and then 100 millitorr vacuum pressure, we're going to hold that vacuum condition about 1080 minutes. Okay, it's a long time. So primary drying will take place for a long time. So how many hours is that? So 1080 minutes divided by 60 equals about 18 hours of drying. We're going to have it. Okay, so once primary drying is done, mostly the major part of the water has got evaporated, but there may be some residual water crystals still existing somewhere in your formulation, right? Those crystal will be further removed by doing a secondary drying. Secondary drying will take place at the higher temperature, because when you increase a higher temperature to a higher condition, normally you achieve a higher vacuum pressure, vapor pressure actually, so you can remove more excessive amount of residual amount of water crystal as well. So you want to increase the temperature from -25 to 25 degrees Celsius. Okay, and then so under the same vacuum pressure condition, so you are slowly just changing the temperature. So as your temperature goes on, there's exponentially increased vapor pressure that's achieved in your vial. So there will be more evaporation that's being achieved. So that's a ramp step. And finally, the secondary drying will be continued under the same condition, 25 degrees for about 240 minutes. That's about 4-hour time point, right? So that's a hold. Okay, H means hold. Okay, so that's the last step. After secondary drying is done, hopefully most of the residual water crystal is also removed. Then you're gonna place your stoppers by lowering the stoppering plate on top of your vials. So manually you can place the stoppers into the vial. So that's a manual stoppering. There's a lever we can use for that. And once that's done, we can release the vacuum and then turn up the freeze dryer and retrieve our vials that are freeze dried. Okay, so that'll be that. So it's going to take a while. So it's going to take total about 25 hours, about 25.6 hours. So it's going to take about a couple of days. Okay, once that's done, we'll do some testing. So again, formulation and freeze drying, we talked about that. Freezing set point is -40 degrees, the lowest temperature, and then condenser temperature is set at -70. So there's the gradient. So condenser is the coolest part of the freeze dryer, and then your shelf is a little low, higher than the condenser temperature, of course, and the vacuum set is set at 100 millitorr. Now that's the parameters. Okay, so once you retrieve your freeze dried drug vials, we'll stopper and then we'll crimp as well. So you will see something like these guys. Okay, if it's well freeze dried, you will see a vial with very good, pharmaceutically elegant freeze dried cake. We call this white fluffy stuff freeze dried part as cake. Okay, called cake. So the good freeze-dried drug product should have very white and solid cake, so it should be pharmaceutically elegant shape. That's what they use to describe the freeze-dried condition, the property of the cake. Okay, so the first thing you want to do is the visual inspection for your cake appearance. Okay, so the good freeze-dried product will have a very good cake appearance, right? So if it's not well freeze-dried drug, then you may have something like that. There's no cake formed, or maybe the cake is kind of loosened up. So these are not good. None of these are good. So you will check the good physical integrity of your freeze-dried cake. That will be the first thing you're going to check. Okay.